Hello student, today we are going to start our new chapter, that is the rearrangement, right? Okay, what is actually happen in the rearrangement? So in rearrangement there is a rearrangement of molecule. So we can say that it is one type of intramolecular rearrangement in a molecule, right? So it's a intramolecular rearrangement. So if I'm giving you some molecule, it is rearranged to some other functionalities, right? So let me first discuss the Benzil Benzilic acid rearrangement. Benzil Benzilic acid rearrangement. Okay, if we discuss about the principle of this reaction, then we can say that here 1,2-dione is converted to alpha hydroxy carboxylic acid, right? So 1,2-dione is converted to alpha hydroxy carboxylic acid by using base, right? So here base catalyzed 1,2-dione, which is your reactant, is converted to alpha hydroxy carboxylic acid. So this reaction, this rearrangement is known as Benzil Benzilic acid rearrangement. So as we can see here that 1,2-dione means dione, here ketone functionality is converted to acid functionality. If we discuss the reaction of this rearrangement, then we can call that, suppose let me take one simple general case of dione. Suppose this is carbon number 1 and this is carbon number 2. So we can say that 1,2-dione. So 2 ketone functionality on reaction with base. It may be either NaOH or KOH, and it is converted to, so we have to showcase the COOH group, right? The product is alpha hydroxy carboxylic acid. So carbon nearer to COOH is known as alpha carbon. This alpha carbon containing OH, so alpha hydroxy carboxylic acid. Now 3 valency of this carbon is already occupied and the 4th valency attached with the R dash. Suppose this is R and this is R dash, so we can call that one is R dash, another one is the R double dash, right? So here 1,2-dione is converted to alpha hydroxy carboxylic acid derivatives. Clear? Let me now moving towards the mechanism part. Okay, so mechanism is important in this case. So as we discussed in earlier that suppose we are using OH minus, then this OH minus can act in 2 ways. Either it acts as a base or it may act as a nucleophile, right? So the role of base is to abstract the proton and nucleophile is attack on that reactant. So any base or any OH minus, any base has 2 type of functionality. It may be act as a base or it may act as a nucleophile. Okay, let me go the mechanism part. Okay, your starting material is R dash, C double bond O, means 1,2-dione functionalities. Okay, now we are adding to OH minus. So in first case here OH minus act as a nucleophile. So this one attack on this carbon. See, both the carbon, we are going to discuss the general mechanism. So we can attack this nucleophile either this position or this position, right? So first one R dash, C and R double dash. So this OH minus attack on this carbon. So here OH, this ketone as it is. Now this OH minus attack at that carbon. So the oxygen is attract the bonding electron pair toward itself. So here O minus. Right? Now as we know that this O minus is not very stable, that's why it again participate in bonding. So here carbon valence is exceeded its 4 valency, that's why this R dash group transfer to nearer carbon, that means nearer keto group. Right? The arrow notation is important over here. This R dash transfer from this carbon to this carbon with their bonding pair of electron, so it's known as anionic shift. Because here carbon, suppose here is the methyl group, so methyl group transfer from this carbon to this carbon with bonding pair of electrons, so it act as a anion type. So C minus transfer to here, right? That's why we know that we can call that it's a anionic shift. So now it is converted to O minus as it is. It is converted to double bond. Here OH. These R dash transfer to here. That's why oxygen attract the bonding pair of electron. So here O minus. Right? R dash comes from the nearer carbon and R double dash is as it is. Clear? Now one important step is there, 1 to H shift, or we can say that simply hydrogen transformation. That means this hydrogen transfer from this carbon or this OH to this oxygen. So here O as it is, OH is converted to O negatively charged, this O negative is converted to OH, R double dash and R is as it is. Clear? Okay, now addition of H plus. Why we are going to add H plus? To stabilize this O minus group, because we want carboxylic acid functionality over here, that's why we are going to add H plus. So now this O is converted to OH, here COH, R double dash and R dash. Right? If we rearrange this molecule, so here C, R double dash, R dash, right? This C is attached with the OH and here is the COOH group. So alpha hydroxy carboxylic acid as a final product. Clear? So first one, attack of the OH minus as a nucleophile. The next step, an ionic shift, that means one group from this carbon to this carbon transfer as an anionic shift. Later on, hydrogen transformation from this O minus to this OH, right? Here hydrogen transfer to this oxygen, and last step, addition of H plus, and the final product is alpha hydroxy carboxylic acid. Clear? Now, here two possibility of OH minus to attack on the carbon. So it may attack on this carbon or it may attack on this carbon. But we can see here that here OH minus is electronically rich. Here OH minus is electronically rich. That's why this always attack on that carbon which are electron deficient as compared to other keto group. Suppose here I am adding to CF3. Suppose this R dash is CF3. To take simple example, and this R dash is the methyl group, right? So in this case, here fluorine is more electronegative as compared to hydrogen, because here CH3 act as a electron donating influence, CF3 act as a electron withdrawing influence. That's why this carbon is electron deficient as compared to this carbon. Is it so? This carbon is electron deficient due to presence of 3 fluorine atom. So OH minus attack on this carbon because it is electronically rich. This carbon is electronically deficient. That's why attack of OH minus is always on the site, always on that ketone which are electronically deficient. Clear? So this is the major challenge to identify the attacking position of OH minus. Okay, let me discuss the application part of benzyl benzylic acid. So first one is the, let me take one simple example, C6H5. Here R is equal to benzene ring. If we are going to add OH minus, right? So in first case, this OH minus act on the, suppose this carbon. It can attack on any of the carbon because both side is same. So OH minus either attack on this ketone or this ketone. Any. So first one, here O minus, here OH, here C6H5, here this ketone is as it is, and here also C6H5. Now this negative charge again participate in the bonding. This phenyl ring as a anionic shift transfer to this ketone, right? This is anionic shift. So here C11O, here OH, CO minus, because this phenyl ring transfer to here, so this bond transfer to oxygen. Now this carbon contain both the R group, means both the phenyl ring. Okay, now H plus transformation. H plus transformation means this hydrogen transfer from here to here. So this OH is converted to O minus, this O minus converted to OH, remaining 2 R group as a phenyl ring is as it is. Now in the last step, addition of H plus. So the here H plus attached with the O minus, and the final product is C6H5. Here also C6H5, right? Here is the OH and here is the COO. So we can say that alpha hydroxy, right? This is alpha carbon. So alpha hydroxy carboxylic acid is the final product. Clear? So in short, we can say that out of this two ketone, one keto group is converted to COOH part. Out of two ketone, one keto group is converted to COOH part. Out of this 2 R group, 1 R group is transferred to 1 carbon. That means both the R group attached with the same carbon, and 1 keto group is transferred to COOH part. Okay, let me discuss the second application. Suppose if we are taking R as a aromatic type functionality, suppose this is our starting material. It is also 1,2-diketone. So as per the concept, this R group transfer to here, and this keto group transfer to this keto group is transferred to COOH. So simply we can say that first draw the cross over here. That means this cross means this carbon group. This carbon group attached with the OH, same attached with the COOH. Now remaining 2 R group arrange here. So one is one furan ring over here, and the second furan ring is here, right? So simple. First draw the cross. One valency satisfied by OH, second valency satisfied by COOH, and 2 R group as it is. So we can say that this is alpha hydroxy carboxylic acid derivatives. Let me discuss the third application. Suppose the keto group in the same ring, 1,2-dione in the same aliphatic cyclic system, right? So as we discussed that the one keto group is transferred to COOH group. Suppose this one is transferred to COOH, right? So the total number of carbon in the ring is 1, 2, 3, 4 and 5, right? So first draw the 5-member ring. This is 5 member ring. Now one keto group transfer to OH, another keto group transfer to COOH. But as we know that COOH and OH both are in the same carbon. Suppose I am putting here COOH and OH. So this is the product, right? One keto group transfer to COOH, one keto group transfer to COOH. That's why the total number of carbon in the ring is 5. Now this keto group transfer to OH, so this is OH. Clear? Number of carbon remains same throughout the reaction, right? Here 6 carbon, here also 6 carbon, here total number of carbon is maintained in this product. Okay, let we discuss the last application. Suppose biphenyl type derivative is there, one keto group here and second keto group here. Clear? So reagent is OH minus. In the last step we are always going to add H plus. So here one keto group transfer to COOH group, another keto group transfer to OH. Make here cross, here COOH and here is the OH. So cross is important, right? Cross is important. So in cross 2, one is COOH group, another OH, and remaining R group attached with that carbon. Clear? So this is the Benzil Benzilic acid rearrangement. So you have to remember that here anionic shift is important. Here OH minus act as a nucleophile, 1,2-dione is the starting material, alpha hydroxy carboxylic acid as a product. Happy learning.